All right, let's jump straight into today's explainer. We are completely unpacking the technical architecture behind the Tayto AI phone ordering agent. We're going to look at exactly how it takes super chaotic, unstructured phone calls and magically turns them into reliable, actionable kitchen tickets. It is a really fascinating look at applied AI in the real world, so let's get right into it. So, to kick things off, I want to frame the exact problem this AI is designed to solve. Just picture the absolute chaos of a fast food branch trying to manage phone orders during peak hours. You know the scene. The kitchen is totally slammed, staff are frantically trying to juggle in person customers, and the phone just keeps ringing in the background. They might try to pick up mid order, or worse, calls just get completely missed. And in this business, every single missed call is a lost ticket, it's lost revenue. So Tayto actually rebuilt their entire phone line as an AI agent specifically to answer these calls, take the orders, and, critically, know exactly when it needs to hand things over to a real human. Here is our roadmap for the explainer. 1. The missed call problem. 2. The architecture where reasoning meets data. 3. Their four-way lookup strategy. 4. Fuzzy matching. 5. Non-negotiable safety guardrails. And 6. Moving from prototype to production. Let's hit it. Okay, section 1. The missed call problem. Defining the strict boundaries of the AI. Now, effective AI really isn't about trying to do absolutely everything. It's about doing specific things flawlessly. So this agent is strictly constrained to 5 very exact tasks. First, it works out which of Tayto's 7 branches the caller is actually trying to reach. Second, it resolves what the caller is saying into real menu items with real prices. Third, it builds the cart. Fourth, it reads the whole order back to get an explicit yes from the customer. And fifth, it creates the order. That's the whole shebang. Those 5 things are its only job. If a caller wants to complain, ask about an allergy, or get a refund, boom, immediately hand it off to human staff. No exceptions. Moving to section 2, architecture. Reasoning meets data. This is the loop behind every caller interaction. Look at the strict, circular shape of this architecture. Every single interaction follows this exact path. Caller audio comes in, the agent backend sends that straight to the Claude model, along with a system prompt and some tool schemas. Then, Claude does the reasoning to decide which tools to call. Next, the tool layer runs those specific calls against the real data, the actual live menu and branch info. Finally, it feeds those structured results back to Claude, which generates the spoken response. It is a continuous, perfectly closed loop. And right here is the absolute most crucial boundary. Claude reasons, but the tool layer holds the data. Claude does not hold prices, it doesn't hold branch coverage, and it definitely doesn't know availability. All of that hard, factual information has to come back from a tool call inside that specific conversation. If a price doesn't come back from a tool result, the AI is literally not allowed to say it out loud. That boundary right there, that's what stops the AI from just hallucinating and making things up. All right, section 3, the 4-way lookup strategy, how they survive incomplete menu data. So what on earth happens when a customer orders something that isn't fully priced in the database? Well, Tayto has 22 menu categories total, but they only hold item-level pricing for 7 of them. That leaves 15 whole categories, things like drinks, coffees, wings, fries, you name it, as massive data gaps. The categories exist in the system, sure, but the specific item prices just aren't in the AI's database yet. A standard, naive AI approach totally faceplants here. A basic agent only has 2 states. It either found the item or it didn't. So if a caller says, "Hey, I'll take a Coke," the naive agent checks its 7 price categories, finds nothing, and literally tells the customer that Tayto doesn't sell drinks, which is obviously false and they just lost an order over a stupid data gap. But the Tayto agent, it uses a super clever 4-state lookup. It intelligently bridges this gap to save the order. Let's break down those 4 states because this is pretty brilliant. State 1 is matched. It found one confident item and just keeps going. State 2 is ambiguous. It found a couple options, so it reads candidates back to the caller to clarify. State 3 is not found. The item is genuinely completely off menu, and it politely says so. But state 4, this is the real game changer. Category known. Using this state, when someone asks for a Coke, the agent recognizes it belongs to the drinks category. It confirms they do serve it, adds it to the cart with a little note, but crucially, it defers the price to the human staff at the branch. It never quotes a fake number, and it never denies selling drinks. That one extra state is the literal difference between a completed order and a customer angrily hanging up. Moving on to section 4, fuzzy matching and ambiguity, translating messy human speech. Let's face it, human callers are just messy. We use slang, a customer will mumble zinger when the actual menu says zapper, Or they'll be shouting jalapeno over a terrible car speakerphone when they actually want the loaded chicken jalapeno. Plus, phone line transcriptions are rarely perfect. So the system uses bigram similarity, basically looking at pairs of consecutive letters, combined with a substring boost against all the item names and aliases. Why go to all that trouble? Because if the AI misunderstands a single word, the kitchen ends up cooking the wrong burger. And in a restaurant, that's a very real physical problem. To manage this chaos, the tool relies on hard mathematical thresholds, specifically 0.82. Any similarity score above 0.82 is considered a rock-solid, single-confident match. If the AI hits that number, it locks the item in and just moves forward with the order. But what if it's lower? Consider the threshold of 0.55. If the similarity score falls somewhere between those two numbers, the tool absolutely refuses to guess. If two menu items sound too similar, it pushes that ambiguity right back onto the caller. The agent will read out the options and just ask them to clarify. Look, asking a caller to repeat themselves is a minor annoyance. Getting their dinner wrong is a total disaster. So ambiguity always goes back to the one person who knows what they actually want, the customer. Okay, Section 5, non-negotiable safety guardrails. This is how they keep the AI securely on the rails. To guarantee this thing operates safely, it runs on 4 hard rules. 1. Never ever state a price that didn't come directly from a tool results in that specific chat. 2. Never create an order without reading the entire thing back, items, total, address, and hearing a clear, explicit yes. 3. Never take credit card details over the phone. They only do cash on delivery or card at the door. And 4. Any mention of an allergy or dietary restriction needs an immediate transfer to human staff. The AI does not get to play doctor or guess about peanut oil based on menu descriptions. And the best part? These aren't just polite suggestions in the prompt. The tool layer is a hard backstop. It will flat out refuse to process a create order command if the cart is empty or missing a delivery address, regardless of what the AI tries to push through. I want to take a second here on this idea of transfer to staff. It is so important to understand that handing off a call to a human, like for an allergy, is not an AI failure. It's actually a designated successful outcome. The real metric of success for this architecture isn't what percentage of calls the agent finishes solo. The metric is the share of calls that end correctly and safely. Getting a dangerous or complex query successfully routed to a human is a huge win. Finally, Section 6, prototype to production, wiring this whole logic up to the real world. So the logic and guardrails we just talked about are fantastic, but moving to a live environment is a totally different beast. You've got to lock the model call server-side behind a secret key for security. You need a massive full menu export to close up those 15 category data gaps we saw earlier. You have to actually wire it up to real functioning branch and order APIs. And, of course, you have to integrate real telephony to handle live speech in and out. The safety logic is there, but that final step is all about heavy lifting to wire it to the physical world. Which leaves us with one final, pretty provocative thought. When you build, is your AI designed to be impressive, or is it designed to be reliable? The Tayto architecture proves a massive point. When you are dealing with real businesses, real kitchens, and real hungry customers, boring reliability, rigid tools, and strict boundaries are going to beat flashy, open-ended intelligence every single time. A hallucination might make a funny screenshot on Twitter, but for a restaurant, it's a lost customer. Thanks for hanging out with me for this explainer. I really hope breaking this down changes how you think about building real-world AI agents.